Today we are diving into the development of a CPF component in PowerApps. We'll explore how to integrate it with the timer control and enhance its functionality using PowerFX. If you are looking to build smarter, more interactive components in your Canvas app, this tutorial is for you. Let's get started. Hi everyone, today I want to show you how you can create a PCF PowerApps Component Framework on your local machine, then import it to your environment on Dataverse. To do that, you have to enable it on your environment. You go to the targeted environment and you click on settings. Then you go to features. It will be under product and click on features, and you scroll down and enable PowerApps Component Framework for Canvas app. Then save it. Once this is done, now you can say that your environment supports custom PCF components. When you are now on your local machine and you want to start PCF development, there are some requirements you need to meet. The first is Node.js, must be installed on your local machine. The second one is Power Platform CLI pack. The third one, of course, is Visual Studio Code. And the last one, in case you may need it, is .NET SDK. To create a new PCF PowerApps Component Framework control, you need to initialize a project using the Power Platform CLI. Let us run the following command in our terminal. In your terminal, you can do it. Back PCF init -- namespace ml taleb -- name lottie PCF, and this is the animation we are going to use -- template, and for template we have two options. Maybe there is another one, but field is normally used for single field controls, like for example custom text inputs, and we have datasets used for multiple records, ideal for displaying tables or lists of data from Dataverse. In our case, in this tutorial, we are going to use field. So field, then -- run npm install. This automatically installs necessary dependencies. Then hit enter. Excellent. Our PCF project has been initialized, and now the dependencies are being installed. When this is done, we can start the development of our custom component. Now we are ready. Let me clear all of this so the screen gets cleaned. Let me open Visual Studio Code using code dots. This will open Visual Studio Code in PCF_solutions folder. Okay. I will explain to you all the necessary folder and files in this project. Let me first open a new terminal. Lottie PCF folder, this is the root folder. You will find subfolders like node modules, contains all installed dependencies from npm install. Now the most important is index.ts. It's a TypeScript file, and it is the main entry point of your PCF control. It contains the class that defines how your control behaves in PowerApps. When you initialize your PCF project, index.ts typically looks like this. This class, LottiePCF, implements component framework .standard control, meaning it must follow the structure of a PCF control. This constructor, this is a standard TypeScript class constructor. It's empty by default but can be used for initializing variable. And now we come to init method. This method is called when the control is first loaded. It provides important parameters, context, contains the control's data, metadata, and properties, notify or output changes, a function to notify PowerApps when values change, and state stores session-specific values, container, a development where the control is rendered. It is here where we create HTML elements like buttons, inputs, and etc. Also, we attach event listeners, and we can apply styles to the UI. Update view method. This method is called whenever input values change. Field is updated in PowerApps, for example. It ensures the UI is always up to date. getOutputs method used to return values to PowerApps. It must return an object matching the iOutputs interface. Destroy method called when the control is removed, for example when navigate away, used for cleaning up memory. Now the manifest types is an auto-generated TypeScript file inside the generated folder. It's created based on our control manifest.input.xml. I will explain that in seconds, and defines the types for the controls, inputs, and outputs. iInputs interface defines all input properties the control can receive from PowerApps. Each property must match what is declared in control manifest.input.xml. Simple property is an example input that receives a string value. iOutputs interface defines what data the control can send back to PowerApps. In this case, simple property is a string output. It is optional. The control manifest.input.xml file is the most important configuration file for your PowerApps Component Framework PCF control. It defines the name and version of your control, the input properties data your control receives from PowerApps, the output properties data your control sends back to PowerApps, the supported platforms, Canvas apps, model-driven apps, and etc. Display-name-key and description-key and control-type defines how the control appears in PowerApps. Namespace, constructor, and version define the namespace and constructor name for the controller. The version helps manage updates. Now, property name, display-name-key, description-key, of-type, required. All of these define a property input for the control. The name, this is the property name used in the interface inputs, iInputs, of-type, single line dot text, the type of data, for example, text, number, etc. Required equal true makes the property mandatory. And for the resources, this lists all files used by the control. If we use external CSS or JavaScript, we add them here. Now, for the sake of time, I've already added some code, and I'll explain it briefly based on what we discussed earlier. The animation URL inputs match the property in control manifest.input.xml. It defines input properties that come from PowerApps, and the animation URL output allows the control to send data back to PowerApps. It defines output properties that PowerApps can read from our control. And if we take a look at the configuration file for PCF, we will find that the URL animation URL input matches the property in control manifest.input.xml. The PCF configuration file. Now that we have defined inputs and outputs, we will update index file to handle data changes and notify PowerApps when the output updates. So this PCF control loads and displays a Lottie animation inside PowerApps using the .lottie-player component. Okay, we see that we import the auto-generated type, I inputs and I outputs that match the control manifest.input.xml file. Also, the class ensures that the PCF follows the expected input and output structure. Player stores the reference to the .lottie player component, and container holds the main div element where the animation will be displayed. Notify output changed a function to notify PowerApps when an output value changed. Not used in this case. You can see the constructor. It is an empty constructor since initialization happens inside the init method. It sets up the controller when it's first added to PowerApps. As you can see, we have some styling that centers the animation both horizontally and vertically inside the container. It also dynamically adds a script tag to load the .lottie player component. Script is imported from CDN pkg.com. This approach avoids manually adding the script in PowerApps. And at the end, it calls update animation function with the initial animation URL. If no URL is provided, it defaults to an empty string. Function update animation updates the Lottie animation whenever the animation URL input changes. If animation URL is empty, it displays a red error message instead of an animation. If there is an existing animation, it removes it before adding a new one. Then we create a .lottie player, set its attributes, animation URL, transparency, etc., and append it to the container to display the animation in PowerApps. Then the update view method updates the animation when the animation URL changes. The get outputs method return an empty object since there are no outputs in this case. The destroy method removes the player to free memory. This PCF control loads a Lottie animation from a URL, dynamically loads the player script, centers the animation, updates it when needed, and clean up resources when removed. That is it. Okay. Now we are starting our PCF control development environment using npm start. Deprecation warning appears. This has no impact on our code and can be ignored for now. Then the control harness starts, launching a local development server at localhost 8181. Everything compiled successfully and we are ready to test. Now here is before us the window where the localhost server is running. And now let me bring an URL for testing. That is pasted just here and see what will happen. Perfect. Excellent. Our component is working perfectly locally. Now let us build it and create a solution, then import it to our environment on Dataverse. First, let me close this window, then stop the server, localhost server, then clean the terminal. For deployment, we need to run npm run build. This will compile our PCF control for deployment, and it shows a deprecation warning that can be ignored for now, and successfully compile the code. Build succeeded and completed without issues, and output is ready. Now to package our control PCF for deployment, we need to create a solution. Inside this solution, we will add the reference to our PCF control. For that, I'm going to create a folder called solutions. So Kadir Solutions. This will create the folder and I will move to it. I will clear the terminal. And now we are going to initialize a solution. To do that, back solution init dash dash publisher dash name. This is creator name, ML Taleb. This case, then dash dash publisher dash prefix. For prefix, I will choose MLT. It should be unique and hit enter. This will initialize a solution. Well, solution has been successfully initialized. Now I need to add into it the reference to our PCF control project. To do that, I need to run this command back solution add reference dash dash path, and here I have to add the path to the parent folder where my project is. Let me explain this. I will copy the path to my project, okay? And let me paste it here. Now I will delete my project from the path. Now I have the path to the parent folder and hit enter. Now I can say that the project has been successfully referenced to the solution. Now we are ready to build our solution. Before pushing the solution to Dataverse, we need to build it. To build it, we are going to run .NET build. This will build the solution in order for us to push it into our environment on Dataverse. Now our solution has been successfully built. Before pushing it, we need to know to which environment on Dataverse we are connected. To do that, we need to run back auth list. This will list all the environments we have on our Dataverse. I see that I'm connected to the right environment. Now I'm going to push the solution to the environment on Dataverse. I need to go one step back to the folder where the project is, or the file of extension.pcf proj is. Once we are in this folder where the file of extension.pcf proj is, we are going to run the command that will push the solution to the environment on Dataverse. The command is back pcf push dash dash publisher dash prefix, and the prefix we have MLT, then we hit enter. This will publish the component to the targeted environment in which we already enabled the PCF for Canvas app. And once this is done, we are going to start building our Canvas app. I'm now on my environment on Dataverse. I'm going to create a Canvas app. I will create it from blank and I will pick Canvas app. I will name it, I will give it a meaningful name. Let us name it animation demo app. Then hit create. Now we can start develop our Canvas app. What we are going to do is we will use a timer controlling a Canvas app to display and hide the CPF. By default, the duration property of the timer is set to 60 seconds, but we will change it to 10 seconds. When the timer starts, the CPF component will appear, and once the timer completes its duration, the component will disappear automatically. And this is why we said the Boolean variable is visible to true on the start, and at the end we toggle it. Now I'm going to import the component. I will navigate to component, then import, and I will navigate to code, and here I can see my component. I will import it. Now to import it to my screen, I will go to insert, then to component code. Under component code, I find it. I just click on it and it's gonna be displayed on the screen. Now I need to provide a URL, and for that we have Lottie Files is an online platform for discovering, creating and sharing Lottie animations. in JSON format. And to get an animation URL, we need to enable its CDN. When we enable its CDN, now this is enabled. I will disable it to show you. I'll disable it, then enable it again. And when I enable it, its link is just below. We copy it and we paste it in our Canvas app. And now I'm going to paste animation URL, load animation URL, and here we go. We have our component, but the error message is always here. And I'm going to fix that in seconds. So let us just test the timer and the component. Then at the end of the timer duration, it will disappear. Great. Let me fix the error here. I will go to the error message, the HTML, and delete it. Then I will rebuild the component. And when I rebuild it, I will republish it again, and everything is gonna be updated on the Dataverse. Okay, that is it. Now it has been rebuilt. Now I will publish it with the same process we did earlier. So now it's gonna be republished again. Now we are going back to the app and re-import it and test it. Now on my Canvas app, I will re-import it. I should refresh first, then I will pick it and import to the app. Now on the app, I should import it on my screen. So under code component, I will find it and I will repaste the URL. Now let me just test it, and I think now is visible is true, and after 10 seconds it's gonna be false and the component should disappear. I hope this was useful, and if you find this video useful, so like it. If not, tell us in the comments below why. Thank you so much.